Okay, so now we have the bulk of the time for the headliner. So thanks to Phil and Boris for joining us today. They're going to talk about the 3D PDF ecosystem. Phil is the customer engagement lead at Elysium and executive director of 3D PDF Consortium. And please correct me if I pronounce that wrong. And then Boris is CEO and co-founder at Dual Lab and a board member for the PDF Association. So one is they're fantastic presenters who sent me the slides in advance, which I always appreciate. So I did get to go through a lot of them. I really love the history that they're going to present on PDF and how 3D has evolved. So I think a lot of good stuff to share. I know there's a lot of folks in the group today that want to know about the 3D ecosystem in PDF and even potentially pathways for USD to get there. So with that said, Boris and Phil, I'm going to stop the screen share and over to you both.
I think Boris is going to do the initial presentation.
Yes, I'm sharing the screen now. Thanks a lot, Patrick, for the intro. And before I go to the slides, I wanted to start or to share the news which came just a few hours ago, and it's not in the slides, but I think it's very much appropriate to the topic of this group as we speak about open standards. So as of now, PDF 2.0 standard, which is ISO 32000 Part 2, is now no-cost access at ISO. Before well, you had to pay something like 200 plus Swiss francs. And now, thanks to sponsors for Adobe, Apprise, and Foxit, the standard is really open. So you can just go and download it. So that's well, excellent news for all who love PDF. And now I start with a presentation. So we call this presentation past, present, and future, just as a teaser. So we'll follow this ideas. So I'll start with the history of how 3D PDF appeared and in which context. Then I'll pass the word to Phil, who will show how it's used today, and I'll then speak about how GLTF fits into the picture. So very quickly, I think the history of PDF can be found on Wikipedia. There is a special article on this. We celebrate today 30 years of PDF. So it's an achievement of a standard being live and very active for 30 years. But one very important thing I would want to stress right from the beginning is that the key feature of PDF, as it was presented back to 1993, and as it stands now, is a high-fidelity 2D rendering. So most important to all PDF users is that PDF documents are rendered identically on all devices and all operating systems. And when we say rendered identically, we mainly mean page content, plain 2D page content. Maybe some other interesting things. So it's highly technical standard because it's a mixture of different technologies. Some of them are relevant to imaging, like fonts, colors, image compression. Some are interactivity, like ECMAScript that sits there. Then there is a cryptography, metadata, semantic tagging today, accessibility. So it's a lot of interchange of many complex features. And this is maybe one of the reasons why PDF still is a very complex well, from technical point of view. And the specification, just to give you an idea, the specification itself, which you can get the latest version as of now from the site of pdfa.org, is over 1,000 pages and keeps growing, actually, because many extensions are still published. Again, I'm back to this main idea that PDF is mainly static content initially. that is guaranteed to be rendered. I put guaranteed into the quotes because it's, well, we see bugs in the implementations from time to time, but in general, I think we all agree that the plain page rendering is very much consistent in web browsers, in PDF viewers, on mobile devices, etc. Now, when it comes to interactivity, and this is also an important feature of PDF today, it's introduced via a very special thing called annotations. And annotations is something that lives on top of a 2D page content. And even such small, well, the simplest kind of interactivity as hyperlink is a rectangle that is placed on top of a page content. And you can specify how it looks like and how it behaves. Well, there are lots of other kinds of interactive features or annotations in PDF today, like we go and comment PDF documents. This is another kind of annotations. We fill in forms in PDF. That's yet another kind of annotation. Well, digital signatures, file attachments, they all come in the similar manner. And this is actually how 3D is located inside PDF. So 3D is this additional supplementary or annotation content in PDF documents, which is commonly placed today under so-called rich media annotations. So it's a category of annotations. And in this category, we find not only 3D, but also video and audio formats. So 3D from PDF point of view is kind of the same as video and audio, which might sound a bit weird initially, but I'll give some more rationale why it is like this. So this slide shows two kinds of rich media annotations. One is video, another is 3D. Why 3D is treated as rich media? First of all, because rich media is based on, well, embedded media files or resources, if you wish. In case of videos, this might be video stream, MP4 files, might be some transcripts. In case of CDs, this is, well, the CD model file plus maybe some additional resources. And all this to render it for the end user, the PDF viewers normally use special rich media players. Might be video players, might be viewers for a particular CD model. And they are almost like standalone applications showing their results in page inside a PDF viewer. Well, historically, we also had Adobe Flash as a part of rich media, but naturally, it's no longer supported. So today, when we speak about rich media, it's mainly 3D, video, and audio. I should also mention another very important feature of PDF. PDF can easily embed a number of other files of arbitrary type. So PDF can serve as a container format. In particular, this becomes crucial in case of GLTF that comes not as a single file, but as a folder of files. So normally one can place the complete family of files or TIFF files into PDF and compress each of those files. So normally all such files come as themes, which are compressed using plate filter. So it's really like a zip file in this case. Well, PDF 2.0 cares about identification of this file sitting inside the document. So for example, it does require the valid MIME type, Unicode name, maybe some extra information that specifies how these embedded files relate to the original document. So any 3D model would sit inside a PDF file exactly in this manner, is a certain file embedded into PDF. Well, so that was a very, very brief intro into PDF technology and the history of PDF. So I'm passing now to Phil, and Phil will show how it works now in practice.
All right, let me go ahead and share my screen. If I can find that, where is it on Zoom? I can't seem to find where I share my screen. I'm not a Zoom guy.
So in the bottom center, there's a green.
Oh, there it is.
screen
The
share.
green thing. The green thing that's right there. I see that. Thank you. Okay.
We see it.
Perfect. Thanks. All right. So we'll talk a little bit about the present. I've been involved in PDF for a long time, since maybe 2010. And what my specialty is, or the area that I'm involved with, is industrial, what I call industrial 3D PDF. So typically it's used in manufacturing or in architecture, in areas where they build things, and because it has a really unique value proposition in those fields, and that it doesn't require a specialized seat of CAD in order to communicate your 3D design, right? You can do that all using PDF, and it's freely viewable using the Adobe Acrobat Reader. Today, Adobe Acrobat Reader is the only commercially available viewer that supports all of the 3D PDF formats that you can write. From the original 1.7 that Boris spoke about all the way up into 2.0 is supported by the Adobe Acrobat Reader. And there's a couple of different types of 3D formats you can put in the PDF file, that U3D and the PRC, and both of those are also supported by Acrobat. Where it has gotten a very large foothold is in manufacturing in the US, right? So manufacturing is making a transition between 2D drawings as being the way that we manufacture things. We've been designing for 3D for a long time, but manufacturing them predominantly off drawings. And now they're moving to a 3D digitalized process for that. And they're using 3D PDF often in order to do that. So at a large scale design house, they'll design in a specific CAD format, and they'll convert that to 3D PDF, and they'll send that to manufacturing. And manufacturing will use that in a number of ways, but they'll first do quality type checking on it, and then they'll do full scale manufacturing. Our request for quotes, RFP, RFQ processes, all those are done. A lot of that is done using 3D PDF today. And it's also very highly used in architecture now, and that's architecture is also making that, AEC is making that same transition between 2D to 3D, moving into being able to really accurately predict, costs and materials and all types of other things associated with the large projects. They call that building information modeling. Now, an interesting thing about both these two use cases is they both use the STEP geometric description. They use a part of the STEP standard to describe all their 3Ds. They're both based on STEP, and that's a lot of the reason why we decided to put STEP into 3D PDF, into PDF. Just recently, we wrote a technical specification to do that. A little bit about the market again, the area growing a lot. The area that I don't have a lot of expertise in is some of these use cases I've seen recently for GLTF around e-commerce and other types of things. I think there could be a close association between the two in the future. PDF certainly is a format that can add, like we're going to talk about the GLTF format, it can add multiple formats to it. So if we want to talk about some of the AR, VR formats, we certainly can do that. It's growing in its use, and it's growing in its market quite a bit. And one of the things that's really propelled 3D PDF in the United States is that we've had a couple of, well, actually in the United States, in these two marketplaces, defense, aerospace and defense, as well as automotive, is there's a couple of standards that are written on them. In the US, there's this MIL standard 31000. That's the Defense Logistic Agency. They use that standard for all RFQ, RFPs, and manufacturing between suppliers and the government, the military, all branches of the military. And then in automotive, in Europe and Germany, there's a VDA association, and they have written a standard 49533-2, and that also incorporates PDF as a container for technical data. And both those are very widely used, and that's been a big proponent or a big reason for adoption of 3D PDF in those marketplaces. Right now, I'm on an automotive committee. We're writing another one, AIAG here in America. We're writing some best practices. I know that the Japan automotive industries doing that as well. So it's been a standard in adoption for quite a while in aerospace and defense, and recently in automotive. Now, let me just real quickly, I thought I had a page in here. Yeah, I'll show you a 3D PDF as well. This is a standard 3D PDF that our company generates, the type of PDF that we generate. They're typically multi-pages. They're designed to replace, as I said, that 2D drawing. So first page tends to be informational, and then we go into the actual 3D data itself. We have these things called views that allow you to organize your data and determine what people can see from a particular filtering of the data, as well as from a viewpoint, camera viewpoint on it as well. We use this, the way that this works is the data format is read into PDF and through the reader, and then they provide all the user interface elements like this view carousel, and we also have a bill of characteristics. So if you want to look at a specific dimension or text notes on the model, you can select that and go directly to it. And all that uses just direct PDF, and it calls a lot of the annotations that Boris was talking about. And then we use JavaScript in order to communicate with the 3D scene, and then change things like the views and other types of things with that. So that is basically the type of 3D PDF that we use in industrial applications today, certainly in manufacturing. All right, and with that, I'll turn it back over to Boris.
Yeah, thanks a lot, Phil. So it's now time to speak a little bit about the future. Well, just to understand where we are, here are the 3D model formats supported, or I hope will be supported soon by PDF standards. So it all started in this U3D format. Well, as far as I understand, little used today. Then followed by PRC. This is a specification, again, designed mostly to model 3D inside PDF. So it appeared shortly after the publication of PDF 1.7 standard. Then very recently, there is an extension to PDF 2.0 that specifies how to use step inside PDF, and I think that's a great move forward, especially for manufacturing. And now we speak about adoption of GLTF as a 3D model inside PDF. It is still in development. So the latest version of the draft specification is in community draft stage, and the latest list of comments will be discussed in May 2 to 5 meetings of ISO TC 171 ST2 in Paris. So if you are interested how it goes and whether the next stage for GLTF in PDF will be maybe DTS or PDTS, which is close to publication, then feel free to register for these meetings either through your standardization bodies in your country or through liaisons. What is that? So GLTF extension. So first of all, this is an extension to PDF 2.0. So this means that this is not a part of the core PDF 2.0, but something similar to extensions we see in GLTF, for example. GLTF has somewhat similar module for extensions. So it will specify how to embed GLTF into PDF as rich media annotation, so similar to PRC and STEP. It will support GLTF 2.0 and the work done on GLTF. The work done on this specification uses ISO version of GLTF 2.0 specification, but as I understand, it's identical to the one published today at Kronos GitHub. It is aimed to support both GLB and JSON formats. In case of JSON, all resources referenced by JSON have to be embedded into PDF. No external resources sitting outside of PDF document are allowed. Embedding GLTF into PDF required adding some new properties into rich media annotations in PDF. So rich media annotations did not have sufficient control on how to activate GLTF inside PDF. For example, unlike any other standards previously supported by PDF, GLTF allows multiple scenes, and the PDF has to know which scene to show. It also has a very rich logic or semantics for defining animations. And again, PDF has nothing to do has had nothing like that before. And there were some extra links or properties going from PDF into GLTF internals. I should also say right from the beginning that it does not include any requirements on how GLTF itself has to be rendered, because this is left to GLTF standard itself and its implementations. So it just says how GLTF is supposed to be packed inside PDF and initialized. To give you an idea how it probably will look like in the future, I show you a live demo. This is a prototype implementation that is required by PDF standards. So whenever a new PDF extension is adopted, there should be some prototype implementation showing how it looks like. So in this case, this is a plugin to Adobe Acrobat that embeds GLTF into PDF. So what you see here is exactly a GLTF sitting inside PDF, and you can view it here. So very much like what Phil was showing before with other 3D models. And what is important is that it is rendered within PDF page. And one can also embed some other GLTFs into PDF. So just as a demo, I will just embed another GLTF, which I have here, animated one this time, and activate it. So as it activates, you see animation is shown within PDF page, and you can specify the type of the animation shown here. So this is how I hope it will work in the final implementations. I don't know when Adobe, certainly we have to wait till the standard is published first before we see implementations, but maybe they will look like this, or even better. So now back to the presentation. Well, in general, when we speak about standardization of new 3D models in PDF, and I've seen that there are ideas about embedding USD into PDF. So we have to understand the following things. So that PDF for the last 15 plus years since publication of PDF 1.7 is developed as an ISO standard by a large international community. So it's no longer the standard that belongs to a single company, as it used to be in very first versions of PDF. And the PDF community is mostly today concentrated around PDF Association, which is the site I was showing to you as a first slide of my presentation. The PDF Association runs a number of working groups and also has keeps liaisons with various ISO technical committees, so that members can take part in the ISO meetings as well. As I mentioned, PDF 2.0 defines a mechanism of adding new features. There's extensions. They are not necessarily, they don't need to be approved by ISO. There might be some custom extensions belonging to a group of companies. But so far, we've seen only ISO-approved extensions, and there are a few already published, like the step one, like the step and PDF is added as such extension is this number. So GLTF, as I mentioned, is developed under also as an ISO extension under the number 30,007. When a new standard is considered, that requires at least probably the resolution coming from either PDF Station. PDF Station has a technical working group devoted to 3D PDF, or even better, by the corresponding ISO working group. Some important points to be considered is, of course, the importance of the standard for the international community, and also the fact that this is a truly open standard, ideally not belonging to a single company. So now maybe to finish, this is the last slide of the presentation, and it lists actually like a list of questions to this group or examples of challenges we faced when we were developing this specification for embedding GLTF into PDF. So first of all, one of the problems was that it was not clear which part is a part of the file format itself, and what is implementation specific. And one of the examples is environment maps, which are not specified by GLTF itself, but are supported and used by a majority of GLTF viewers. So it's not clear how one can use environments if environment maps within PDF viewers, because there is an assumption at least that if a GLTF model is embedded into PDF, and then different PDF viewers that support GLTF should render it identically. The other challenge is that, well, there are some issues with color spaces like RGB and sRGB. Like PDF has strong preference towards color device-independent color spaces like sRGB, but it's a non-linear color space, so it's not clear whether it is a good blending color space for GLTF rendering. But again, that's left for implementations to decide for now. Also, PDF has internal data structures that define lights, and again, maybe this is a bit outdated, and I don't understand that GLTF is certainly following more modern practices in 3D rendering. So there might be some collisions, and we are still not aware of them, but as we come to the implementations, there might be some collisions between PDF-based light definitions and, for example, GLTF PBR materials. Well, metadata, again, PDF has the concept of metadata from the first days, and also metadata plays an important role in GLTF. So there might be conflicts. So for the moment, the draft specification says just that if some metadata is duplicated, it should be in sync. But we hope that's sufficient for now. But this is yet another point of conflict. And finally, I put it as a last item. That's probably the most controversial, difficult one, is interactivity. So as we've seen in the demo of Phil, there is an assumption that there is a link. The interactivity of PDF is linked to the interactivity in 3D models, so one can click to some elements on PDF page and would see how the view of PDF model is changing. It is not clear for the moment how it will work. Officially, there is an ECMAScript 3D ECMAScript supported by PDF, but there is a feeling it's not clear how soon PDF viewers will be able to support it. So, well, I hope there will be some level of support, but it's again beyond the extension that just defines how GLTF data sits inside PDF. Well, that's probably it for now. This is the end of our presentation. So as I understand, it's a QA time now.
Well, first, thank you guys. That was really awesome to to see the history and the evolution, and also those interesting challenges on that kind of seam between PDF and 3D. I'm sure there's going to be a ton of questions. I see Ed very carefully put his hand up right at the end. So Ed, you want to kick things off?
Sure. I guess I can speak authoritatively to the sRGB question. Yes, in GLTF we carefully define which input textures are in sRGB color space and which ones are non-color for things like metallic values, occlusion values, that sort of thing. So those values inside the GLTF are known coming in, and then how you output them is more up to the viewer. If you need to blend them in the color space of your choosing, GLTF doesn't specify anything in particular about that. You can choose your own blending algorithm there, but the rendering of GLTF, there shouldn't be any question as to what color space your source material is in. That's all pretty well nailed down. We have test models for that in the sample repository, that sort of thing. I think it's very interesting, the question of what do you do about the environment, because a given GLTF asset can look very different under different lighting in different environments. And we sort of intentionally, we've had some attempts to make some extensions. There is a vendor extension out there somewhere that tries to include the environment in the GLTF file, but everyone wants to mix and match. Ooh, try this asset in this environment. Try try changing this other. And so we end up not storing the environment in the GLTF file itself for the most part. That may be something you consider separately in PDF. Maybe the PDF has a GLTF and also has a EXR or HDR or some kind of file in there as well to be the environment around that GLTF. I don't know. But there's options there. I see a lot of other hands up, so I should probably stop talking here. But
well, Boris, did you have any quick responses to that before we move on?
Yeah. So I think with respect to blending color space, we were a little bit confused by the requirement somewhere in GLTF spec that a blending space has to be linear. So the sRGB is not linear, so it was not clear whether it's a hard requirement or it's just a recommendation or.
All of our PBR calculations happen in terms of energy, how much light energy is being transmitted, and so the first thing that happens is the sRGB textures have to come out of sRGB mode. So that is specifically the base color, the emissive color, and any other texture that has color in the name, basically, is presented in sRGB mode to the GLTF because that's what people have authored it in with their programs. but it immediately comes out of sRGB. It goes through an sRGB to linear transfer function, because the next thing we need to know is how much light energy is there, and we want to preserve, we want to be energy conserving bidirectionally, which is PBR speak for we don't want to lose track of light energy as it goes through the PBR equations. And so we do all that in linear space without sRGB. And then at the end, a typical GLTF viewer, at the end, the very last step is it has to convert it back to sRGB just to put it on the screen. Because otherwise it's you know, you were doing all these energy calculations in non-color space, and now you have to get it back into sRGB just to throw it onto a monitor and look at it. So that's the typical end of the pipeline, is the very last step, it all goes back into sRGB. But again, if you need to do alpha blending or something prior to that or after to that's sort of your choice. The GLTF spec doesn't say too much about that, as far as I know. Alexi K may disagree with me. He's another good person to ask about this. So you can talk to him as well.
Yeah, again, that's technical details we certainly lack in knowledge about. But in principle, well, from the PDF point of view, if it's all like a black box responsibility for the GLTF rendering engine, then it's probably fully okay to PDF. It's just important that what it comes out of rendering is also sRGB, as you're saying, and then it's perfectly okay to show this within PDF page, which is probably rendered within some output color space. And for the environment, we really need to learn what it is. If it's just an image, a 2D image that can be placed as an X-ray source into PDF, that would also be fully acceptable.
So Boris, Ed, could I just send an email that connects you two, and maybe Ed could point you to some resources?
Absolutely, sure. Yeah, I'd love to.
Okay, cool. Well then, since I know there's a bunch more questions, if we could maybe move on. Yeah. I know, Michael, you want to go?
Yeah, I wanted to raise two topics. So first, you mentioned that in extensions, things don't have to already be ISO standards. So in particular, I think to this crowd, USD is an interesting one to talk about. So what would be involved in writing a USD extension for PDF, and what does that API look like for the extension? Is it something that, for example, if you wanted to make an extension onto Acrobat, that would have to be done by Adobe, or could other people do it?
Well, these are two different things here. So we speak about file format and implementation. So from the file format point of view, it's defining data structures, how exactly the standard is packed into PDF, what are the extra properties that have to be specified when the viewer is initialized, for example, some data that has to be passed to the viewer as a instance, well, PDF, we call it instantiation or activation of a rich media annotation. So that is relatively simple. In general, it went quite smooth in case of STEP, and I hope it will be with this kind of file format requirements will pass through quite smoothly for GLTF. If it comes to USD, and there's, I hear some desire to have USD also placed on the PDF as an ISO extension. That's most importantly, I think people from PDF world have to understand what is USD and why it is important to have it inside PDF for whatever applications, industries, communities. And the best thing is to give a presentation on this topic. Well, probably we can invite anybody who wants to give such presentation to one of the meetings of 3D PDF technical working group within PDF Association. That's essentially the same people that sit them in the corresponding ISO working group, but inside PDF Association is way much less formal and much easier to discuss things, and much faster as well. The second question is implementations. Whoever implements PDF viewers would be able to pick up the specification and implement yet another 3D model. It just the companies that implements the PDF viewers has to be interested in this, and probably there should be some market around this feature so that the companies like maybe Adobe or Foxit or maybe some other would go and implement this. So it's certainly beyond the standardization efforts.
Right. No, so there's no, do any of those PDF viewers actually have plugin architectures that would allow people other than their creators to make those extensions, or do they have to be done by the creators of those, you know, for example, Adobe for Acrobat or anybody else?
What I was demoing to you is a plugin for Adobe Acrobat Professional. I know how plugins for Adobe Acrobat are developed. Some other viewers, like Foxit viewer, may have its own plugin infrastructure. In case of Adobe, the SDK is open, and anybody can develop plugins for Adobe Acrobat. It's important that this will work only for Adobe Acrobat Professional, not for Adobe Reader. For Adobe Reader, Adobe has much stricter policy, and it's almost impossible to pass through. Well, probably I have. I don't know if anybody except Adobe was able to implement plugins for Adobe Reader, because they really care about safety of this application.
Okay, so another topic in terms of the interactivity, it's all currently based on JavaScript. Is there any appetite for WebAssembly? The nice thing about WebAssembly is then you can use other sources, like you can have, for example, USD, the library is itself written in mainly C++, but if PDF were to support WebAssembly, we could use Inscriptum, turn it into WebAssembly, as we've done for the web, and that would be a way of bringing it into PDF.
That's certainly a very, very interesting topic for discussion. I probably don't have much time now for this. In general, it might have conflicts with security, and Adobe is really concerned about security, and many other vendors around PDF are really concerned about security. We have to understand that this web assemblies will go wild, and somebody has to ensure that there are no security holes in there and no concerns. Again, as you're saying, indeed, it works already in web world. So potentially all the security issues are tackled in web world as well. A little bit of a problem is that PDF is a document format. So when PDF document is rendered, there is no server, so to say. So there is no way to put a certificate saying that this data comes from this server and this server is responsible for this data. So
I don't think that's necessary, right? I mean, it's essentially the same situation that a web browser is in, right? It loads, a web browser loads up WebAssembly. The WebAssembly doesn't need to be signed by anybody. It executes it in a sandbox environment, very much like the JavaScript environment, but something like Chromium V8 provides, not just the JavaScript environment, but also the WebAssembly virtual machine, so that there's no additional need to know where any of the data came from.
Yeah, well, that's certainly that might be a way to go, but I certainly lack necessary technical skills to discuss this right now. So I'd be happy to learn this. Just to repeat that, that's a very sensitive question and might have resistance in the PDF industry.
I would say that, yeah, we would be very interested in talking about that. Certainly at the 3D PDF technical working group level. I think that we'd be very happy to do that, to discuss that.
Michael, would you want me to send an email intro to Boris and Phil?
Sure, that'd be great.
Thank you very much.
Sure. And then Chuck, I know you had your hand up at one point and you dropped a question in chat as well about, are the assets hosted, they're referenced in a PDF? Did you want to talk to that?
Sounded like some of that might have been already addressed, but I was just curious to manage file size, where either 3D or video assets would be hosted. It sounded like you talked a little bit about that, but would love some clarity just in terms of managing file sizes and also addressing security.
That all goes inside PDF. So all assets are required to sit inside a single PDF document. As I say, they can be compressed. And for the moment, PDF supports only, it supports a few compression algorithms that are good for assets. Maybe plate is the most typical one. But yes, that's certainly, so 3D PDF files usually come quite large if it is a real 3D file, because it's everything packed into a single document. Well, very similar maybe to GLB as well, because GLB does about the same thing, as I understand.
So with a 3D model, like the one that was showing in the presentation, the valve or whatever, the layers, lighting, camera effects, all the things we packed into that single PDF, and we have to house file size, all of that data.
Yep.
Understood.
So if I go and look for any 2D, any GLTF models in JSON format, I see like a collection of assets. They will all be packed in a T-like structure inside PDF, like a virtual file system in a way.
Thank you.
Great. Neil?
Yeah, just a super quick question to Boris. Just logistically, that slide with the challenges, GLTF challenges, was very interesting. Are they solved challenges or are they live challenges? If they're still live, we should perhaps arrange a separate meeting with the GLTF folks to help you get those resolved.
For the moment, they are left to the implementations. So we assume that we know how to pack GLTF into PDF, and these challenges are to the implementers.
Okay.
So packing GLTF in PDF is kind of resolved. I think we resolved all the questions there, and I'm not allowed probably to speak about the standardization efforts as they go, because the ballot has.
Sure.
I think ballot results are not yet out. But I will certainly keep you updated after May meetings.
Okay. All right. Cool. So we're not blocking the balloting. No. Okay. Cool. But
actually, the only blocking question is that somehow MIME type for GLTF JSON still mentions only GLTF 1.0, not 2.0.
Oh, interesting. Yeah. Okay. Well, we can take that one. Yeah, and we can follow up and help on the implementation questions down the line. Yep.
Yep.
Great. Other questions for Boris or Phil? Cool. Boris or Phil, did you have other questions for the group?
Well, we certainly would want to keep on discussing technical questions. So yes, Patrick, if you connect us to the right people in the group, we'd be very, very glad. And and we had a few discussions here that require more time, and we'd be happy to invite people to the corresponding 3D PDF working group within PDF station to give presentations, exchange ideas.